All right, here is part 4 of section 4 of this redesigned SAT practice test 1. In this video, I'm going to work on problems 26 through 30 of this test. So in previous videos, as you can kind of see here as I scroll through quickly, I did 1 through 10, 11 through 20, and 21 through 25. So that gets me down here to 26, where I will pick up. So 26 says, Katrina is a botanist studying the production of pears by two types of pear trees. She noticed that, you can skip that first sentence as you often can in these SAT problems. She noticed that type A trees produce 20% more pears than type B trees did. So type A produced 20% more, so 1.20, than type B. You can kind of make this an equation by writing it like this. Based on Katrina's observations, if the type A trees produced 144 pears, how many pears did the type B trees produce? Well, all I got to do is say you're telling me A is 144, and I've already set up this equation that models what's going on, the difference between types A and B. I can solve for B. Divide by 1.20. You get that B is 144 divided by 1.2, which I think gives you 120 if you plug that into a calculator. That's because 12 times 12 is 144, whatever. Trust me, it's 120. Plug it into a calculator. See for yourself. If you didn't like setting it up that way, you could go through and check these. Is 20% more than 120 equal to 144? Right? Figure out what is 20% of each of these guys. Well, to figure out 20%, like if you tip 20%, it's relatively easy. You just double this number and then move the decimal place one to the left, I guess. So if you double this number, you get 210. So you move that decimal place over, you get 21. You double this number, you get 240. You double this number, you'd get 24.8. And double this one, and you get some huge number, 346. And you move that over, you get 34.6. So what I'm saying is 20% of these numbers are these amounts. So what I'm looking for, these are the type B amounts. And I know that 20% more, if I add up these numbers, I should be getting 144. Well, the only place that will be true will be in this one. So if you didn't like this equation way of solving it, as you often can on these, you can kind of go through and, I don't know if guess and check is the right phrase to use. The downside to that is it typically takes a little bit longer than setting them up with the equation. 27. Square field measures 10 by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is 1 by 1. Okay, so I got 100 total square meters to deal with. This is my big field. And then I got 10 students who each kind of take a 1 by 1 chunk. 1, 2, 3, 6, 7, 8, 9. I think I counted those off. Here's what the students do. Note that I still have a lot more to look at here. So they're looking for earthworms. They count this many. The question is asking which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field. That's tricky. So I only looked at this part of the field. I only looked at 10 square meters. The entire field is 100 square meters. So what I want to do is figure out how many earthworms I found in 10 square meters, and then multiply that by 10 to get the total amount for 100 square meters. So I got to add up all these numbers. I don't really feel like adding up all these numbers. But if I just kind of glance at these, it looks like they're pretty close to 150, right? Some below, some above, but the average in here is about 150. And there's 10 different students. So if 10 students found on average 150, they found 1,500 earthworms total in this 10 square meter region. But I'm not asked about this 10 square meter region. I'm asked about this 100 square meter region. So I have to take this number and multiply it by 10 to get 15,000, which would be the approximate number of earthworms in the 100 meter squared field. 28. If the system of inequalities y is greater than or equal to 2x plus 1 and y is greater than 1/2 x minus 1 is graphed, which quadrant contains no solutions to the system? Okay, so maybe we go ahead and graph them. If you think about this like y equals mx plus b, the y-intercept is positive 1, which maybe I'll put a scale on this. Here's positive 1. And the slope is 2, so I go up by 2 every time I go over by 1. If I'm drawing the line y equals 2x plus 1, it looks something like that. I wish that were a straighter line, but we'll call that good. If I were drawing the line y equals 1/2 x minus 1, I'd put the y-intercept at at negative 1, and then the slope would be 1/2, meaning every time I go up by 1, I go right by 2. So I would be talking about this line right here. So this is y equals 1/2 x minus 1. But you're like, you don't want y equals 1/2 x minus 1 and y equals 2x plus 1. You want y is greater than or equal to 2x plus 1. So we're talking about all the stuff that's above this line. And we're talking about all the stuff that is above the 1/2 x minus 1 line. So really what I'm looking for is the region that is above both of these lines. So I'm talking about this region right here. Note that there are points in region 1, quadrant 1, quadrant 2, quadrant 3, but nothing in quadrant 4. And you're like, what about right here? That's above this line. Right, but it's not above this line here. So there are no solutions in quadrant 4. So when it asks me which quadrant contains no solutions, I would say C, quadrant 4. 29, you got this polynomial. The value of P of 3 is -2. So you're not given a whole lot of information. You know you have some polynomial. You don't know the degree of the polynomial. But you do know that when you change all the x's into 3's, what comes out, the y value, is -2. And they're asking you which of the following must be true. So this is kind of a tricky question. The first one, x minus 5 is a factor of P of x. Now, you don't know anything about factors of P of x. The only way you get information about factors of P of x is if you plug in a number and 0 comes out. Knowing what comes out when you put 3 in gives you no information about what comes out when you put 5 in, or 2 in, or -2 in. None of these can be the solution. The only possibility in this problem is D. It'll turn out that D is true. The remainder, when you divide by x minus 3, is -2. One way you could prove that to yourself is by taking the simplest polynomial you can think of, where P of 3 is -2. So there's lots of different polynomials where that is true, but P of x equals -2 is one that I can think of, the simplest possible, a good counterexample. If I change all the x's on the right side of this equation into 3's, it's going to be equal to -2. You're like, I don't see any x's. Exactly. For any value of x, this thing is equal to -2. Is x minus 5 a factor of this guy? No. You can't. No, absolutely not. You can't divide -2 by x minus 5. What about x minus 2? Nope. Could you factor -2 so that it's x minus 2 times something else? No. No. The remainder when you divide by x minus 3 is -2. That's true. How can that be true? What happens when you divide by x minus 3? Well, the idea is we would take 0 times x minus 3 in this specific case. We could rewrite our polynomial like this, and that would make that happen. But this is just for this one specific counterexample. This will work for any polynomial. If you know that P of 3 equals -2, then what you know is that the remainder when you divide by x minus 3 is equal to -2. What about 30? 30, you're given this graph here, x squared minus 2x minus 15. And you might be like, I can factor that. I'm really good at factoring. I spent lots of time factoring. This factors into x minus 5 times x plus 3. And I'm like, yeah, that's right. That's great, but that's not the answer. It's true, but that's not the answer. Because if you read the question carefully, it says, which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants in the equation? So what you need to know is that this point right here, A, this vertex, where is it? Well, its x-coordinate is clearly at 1. What's its y-coordinate? It kind of looks like -15, but it's hard to tell the way it's drawn. It'll turn out it's actually -16. The way you can prove that is its y-coordinate is what comes out when you change all the x's into 1's. If I do 1 squared minus 2 times 1 minus 15, I get 1 minus 2 minus 15, which is equal to -16. So this point right here is at +1, -16. So what I'm looking for is which of these guys have a +1 and a -16 in them. Hey, D does. This doesn't, this doesn't, this doesn't. My answer must be D. If you don't feel good about that, if you're not sure that D is in fact equal to this, it is, but maybe you don't feel good about that, you can show that it is. If you FOIL out x minus 1 squared, you'll get x squared minus 2x plus 1. And then if you subtract 16, you get x squared minus 2x minus 15, which is exactly what the original equation was up here. So in fact, D is equal to this equation. And the nice thing about D is it's got a 1 and a negative 16 in it, which are the coordinates of the vertex. And those don't show up in any of these other forms. Some of them, x minus 5 times x plus 3, right here, is equivalent. This one might be equivalent too. Let's see, x squared minus 2x minus 15. Yeah, a bunch of these guys are equivalent to this guy, but they do not identify the coordinates of the vertex as constants in the equation. In case you were curious, and I don't know if you're curious or not, the way you can get from here to here is what's called completing the square. That's one way to get from there to there. I don't think I'm going to bother showing you completing the square at this point. If you're talking about the vertex, the x-coordinate of the vertex is always negative b over 2a. So if you have some polynomial, ax squared plus bx plus c, you can always take the a and the b and plug them in here, and that'll give you the x-coordinate of the vertex. So negative b over 2a, that's a good thing to memorize. That'll come in handy when you're trying to find the x-coordinate of the vertex. In this case, I didn't have to find the x-coordinate of the vertex because I had a picture of it right here. It's clearly at 1. But if you didn't have this picture, you could have said, okay, a is equal to 1 and b is equal to negative 2. And so negative negative 2 is positive 2. Divided by 2 times 1, that gives me 1, which in fact was the x-coordinate of the vertex. All right, I'll end that here.